Hello, my name is John Thompson. I'm with Alscom LLC located in Alpharetta, Georgia. I'll be presenting today on behalf of my co-authors, Dr. Randy Mitchell of Purdue Foods in Salisbury, Maryland, and Dr. Ulrika Braun of Alscom GmbH in Trostberg, Germany. Our title today is Muscle Creatine Content and Severity of Woody Breast in Male Broilers Fed Varying Levels of Guanidinoacetic Acid. Woody breast is a meat quality defect which has been associated with fast growth rates and higher breast meat yields in broiler chickens. These features have led researchers to conclude that energy metabolism is implicated in the syndrome. Severely affected breast meat has an objectionable texture and may need to be downgraded for use in lower quality, lower value products. Guanidinoacetic acid is the immediate precursor of creatine and is currently approved as a feed additive for poultry in the U.S. and a number of other countries. Previous workers have reported improvements in woody breast score severity in broilers fed diet supplemented with 0.06% GAA. The objective of the current study was to explore the effects of GAA supplementation on growth, feed intake, meat quality, and muscle creatine and creatinine in broilers under U.S. industry type conditions and grown to heavier weights as is common in many broiler complexes. This trial was conducted at the Purdue Foods Research Facility in Westover, Maryland. Day-old male raw 708 chicks were allocated 46 birds per pen to 30 pens and blocked on location within the room. 10 pens were randomly assigned to each of the three treatments. Treatment 1 was the corn soybean meal-based control feed. Treatment 2 was as treatment 1 but with 0.06% GAA from Creamino, which is a 96% GAA supplement. And treatment 3 was as treatment 1 but with 0.06% GAA in the starter and grower phases and 0.08% GAA in the finisher 1 and finisher 2 phases. Feeding phases were starter day 1 through 13, grower day 14 through 27, finisher 1 day 28 through 41, and finisher 2 day 42 to 53. Feed and water were available ad libitum throughout the trial. Feed intake and live weight were recorded on days 27, 41, and 53. At processing on day 53, 6 birds per pen were randomly selected for breast meat yield and creatinine analysis. A sample of breast from these birds were evaluated for woody breast and scored either normal, semi-hard, or hard. The numbers used were 30 for treatment 1, 46 for treatment 2, and 33 for treatment 3. Statistical analyses were as follows. Performance data were analyzed as a linear mixed model with pen within block as the random effect. The effect of live weight on woody breast category was analyzed by logistic regression. Muscle creatine and creatinine versus woody breast and treatment were analyzed by one-way ANOVA. Treatment effects on breast meat quality were compared by Fisher's exact test. All analyses were conducted using the R programming language. A mixing error in the finisher feeds resulted in a disproportionate increase in protein content in the control diet, so I'll only present performance data up to day 27. Unadjusted FCR was lower for T3 than T1, with T2 intermediate between the others. Due to a higher mortality rate in the control birds, mortality-adjusted FCR was not different. Day 53 unadjusted FCR was numerically improved with GAA, though higher mortality in the control group erased these differences in mortality-adjusted FCR. Ordinal logistic analysis showed a significant effect of live weight on woody breast category, such that an increase in live weight of 103 grams above the average of normal bird weights was associated with a 1 category increase in severity of woody breast. Assuming the most severe category carries the highest economic cost, data were recoded to acceptable, which was the normal plus the semi-hard category, versus downgrade, which was the hard category. Live weight had a significant coefficient of 2.96, which can be interpreted to mean that 100 grams of increase in live weight above the average of the acceptable birds nearly doubled the odds of downgrade. Effects of dietary treatment were evaluated using counts of woody breast categories and analyzed by Fisher's exact test. Percentages were not significantly different, with a p-value equal to 0.161. Numerically, feeding GAA reduced the hard breast by 4.8 to 9.1 percentage points. A power analysis showed that this level of replication in the current trial only had about a 16% chance of finding a 9.1 unit improvement. As seen previously, GAA increases muscle creatine content. Here also increasing GAA intake, 2 versus 3, increased the creatine content as well. Creatinine, which is the spontaneous breakdown product of creatine, increased with GAA feeding, but was not further increased with higher levels of GAA intake. In agreement with our previous unpublished data, creatine was found to decrease with the increasing severity of woody breast. In conclusion, guanidinoacetic acid at an inclusion rate of 600 grams per ton improved unadjusted feed conversion rate from day 1 to 27 when compared to control-fed birds. Breast muscle creatine increased as total GAA intake increased. Breast creatinine levels were low and increased marginally with GAA intake. Increased woody breast severity was associated with increased live weight, such that a 103 gram increase above the mean weight of normal birds favored an increase of one severity category. Increasing live weight by 100 grams above the average of acceptable birds nearly doubled the odds of downgrading breast meat. Breast meat creatine content decreased as severity of woody breasts increased. The percentage of breast meat grading hard decreased by 4.8 to 9.1 percentage points in GAA-fed birds versus control-fed birds, though the differences were not significant. The power of the statistical test used to evaluate the GAA effect on woody breast in this trial was estimated to be 0.16. Reductions in the proportion of the breast meat downgraded to the hard category on the order of those seen in this trial would have large economic benefits. Data from this trial and similar trials will be valuable in designing future trials with sufficient power to statistically verify responses at economically important levels. Thank you for your attention.